Welcome to this APC mock interview practice session, where today we're going to take a look at some core competency questions for the building surveying pathway, and we're going to look at each question in depth and explain some of the answers you can give, and I really hope this practice interview will improve your understanding of the core competencies and also give a much better understanding of what to expect during the final assessment interview and how this is structured. We'll also cover some of the optional competencies towards the back end of the interview, so hopefully this will give a good insight into these and may help you decide on your optional competencies. Whilst I can't claim to be an expert or an APC assessor, I'm only speaking from my own experience of the APC and having helped a number of colleagues pass their APC over the last 6 years, and I really hope you find this video useful. So before we go into the main Q&A practice, let's first of all explain when the core competency questions will come up during your interview. You can see the interview starts with a brief introduction by the chairperson, and this then leads into your case study presentation. Following your presentation, there are then 10 minutes of Q&A around your case study, followed by 25 minutes of questioning on the core competencies, and this is a section that we'll be focusing on today, highlighted in green. And also remember that most of the questioning you face will be based on what you populate within your submission documents, so really try to base the majority of your revision around the topics that you have referenced within your submission. Always remember that the APC is personal to you, so please don't feel overwhelmed by the final assessment interview, as it is largely based on your own experience. If you're unsure about how to achieve each of the competencies or how to populate your summary of experience, I did do a separate video on this which I'd really recommend watching. It may be the case that you're currently struggling for case study ideas or how to structure your case study, and again I did do a separate video on this which I'd really recommend watching. The next competency we'll take a look at is building pathology. And the first question we'll take a look at under this competency is what are the typical defects of a flat roof and what are the remedies? And to address this question, first of all we can mention a typical defect with a flat roof is crazing. And surface grazing is caused where there is a lack of adequate protection from the harmful effects of exposure to the sun, or in rare conditions a chemical attack. If this is only in a small localized patch, then no treatment is necessary but should be regularly rechecked. However, if it's more widespread, the areas will have to be re-roofed and specialist protection introduced. Another common defect we could reference is blistering, and blisters can be caused by water vapour pressure occurring below the roof covering, and the blister should be cut and then rebonded to the underlay, allowing any trapped moisture to escape first. The source of the moisture should also be traced and rectified. And these are typical examples of crazing and blistering that we can see in the shown photos. Another question we may be asked is what other sorts of cracks would you expect to see on a brick building and what may have caused them? And to address this, first of all we could reference subsidence, and this is a movement down in the ground level, and this can occur in clay soil where the growth of large trees which remove water from the ground can cause this, and this can lead to vertical cracking if in the centre of a building or diagonal cracking if at the corner of a property, and the cracks will be larger at the top and thinner at the bottom. We could also reference a ground heave, and this is a upward movement in the ground level. And in clay soil, the removal of a tree will often increase the moisture content of the soil, and this could cause the soil to swell or the ground to swell. And this leads to vertical cracking, again if at the centre of the building, or diagonal cracking if at the corner of the property. We could also reference a settlement, which is a downward movement due to an increased load of a building. Typically buildings will settle when first constructed, or if there is a change in the load as a new load settles and increases the bearing capacity on the soil. And these are some diagrams showing the different types of causation of cracks within buildings, including the heave, subsidence and settlement. Another question we may be asked under the building pathology competency is checking our understanding of the term damp or dampness in buildings, and to address this we can say that a building is only considered to be damp if the moisture becomes visible through the discoloration and staining of finishes, or causes growth of mould, sulfate attack, frost damage, or even drips and puddles are prevalent in the property. A follow-on question we may be asked in relation to damp is how could you test for dampness within properties? And to address this we could say that we would use a protometer, moisture reader, or speedy carbide meter, and this can be used to establish the moisture content of walls and the level of damp that's prevalent within the property. We may also be asked a question on how to identify rising damp, what are the causes, and how would we look to remedy rising damp. And to address this, we could say that rising damp causes high tide marks, peeling and blistering of wall finishes, musty smell. It can also cause rotting timber, and a use of a speedy carbide meter can be used to measure moisture readings within the walls of a property, and the readings with the moisture meter will result in high surface readings, often with slight decline, finishing with a sudden cut-off. The causes of rising damp can include where there is no damp-proof course in place, or there may be damp-proof course bridging caused by pointing, render, soil, or paving, or mortar droppings. And the remedy for rising damp can include remedy to any damp-proof course issues. This can include removal of any sources of bridging, and also a chemically injected DPC. We may also be asked a question on what type of soil is susceptible to ground heave and what are the potential or possible causes. And to address this, we can say that cohesive soils such as clay are often susceptible to ground heave. Possible causes could include the removal of trees, a change in the water table, leaking drains, or inadequate foundations that are built within the movement zones. And the last question we'll take a look at under building pathology is what are the common defects associated with flat roofs. And to address this, we can say that common defects include blistering or splitting of coverings, sagging due to failure of decking between joists, ponding due to insufficient falls, and damages to flashings and inadequate solar protection. We'll now take a look at some questions that are focused on the inspection competency. The first question we'll take a look at under the inspection competency is what do you need to consider before going to site to carry out an inspection? And first of all, we can reference the consideration whether we are competent to undertake the inspection. We also need to ask ourselves, are we properly insured? Whether a formal agreement has been signed by the client and is in place prior to undertaking the inspection. What are the particular risks that we need to consider in regards to health and safety, working at height, any presence of asbestos, for example. We'd also need to consider what kind of survey it is that we are undertaking, and also review all relevant information that relates to the existing building information, any leases and transaction prices. And finally, which type of equipment we would need to take along in order to carry out the survey. We may also be asked a follow-up question to this, checking our approach and understanding of how we would go about undertaking an inspection of a property. And to address this, we could say that my own personal preference when undertaking inspections has been to undertake these from the top floor of the property, working my way down. In the past, I've normally walked around the building externally a couple of times, first of all to get my bearings and get an initial understanding, paying close attention to the indication of age, the form of construction, and any extensions and external defects. I then started the inspection externally by inspecting each elevation in turn, looking at the roof, elevations, windows, doors, drainage, and any rainwater goods. I would then typically move inside and again start from the roof space and move down through the various floors of the property. We may also receive a question from the assessors asking what kind of risks we would need to consider, and to address this we could first of all reference the risk of lone working, the presence of any asbestos, our ability to access roof spaces at height, our ability to access roofs and roof spaces, and in particular the risks associated with working at height. We'd also need to consider any hazards associated with the derelict nature of the property or the empty property, and also any risks associated with working within confined spaces. We may also get a question from the assessors checking our understanding of the equipment associated with undertaking property inspections. And in this example, we may get asked a question on our understanding of how a disto laser measure works and how we would go about checking whether this is accurate. And to address this, we could first of all say that the disto sends out a laser beam and measures the time taken for it to reflect, which then generates a distance. We could check this by first of all using a known measured distance within the office prior to undertaking the inspection. And we'd also need to say that it would become less accurate the longer the distance, and also reference that it's particularly difficult to use this piece of equipment outside over long distances because it is difficult to aim and see the laser. The next question we'll take a look at is, have you heard of a theodolite and how does this work? And to address this, we could say that the theodolite is an optical instrument consisting of a small mounted telescope which is rotatable in both horizontal and vertical planes, and this is used to measure angles in both horizontal and vertical instances. The telescope is mounted on a tripod with adjustable legs, and the theodolite is then used in the field to obtain precise angular measurements for triangulation, and levelling can also be accomplished with the aid of a spirit level, using crosshairs in the telescope, and this would permit accurate alignment with the objective being sighted. We may also get a question on our understanding of a hygrometer, and to address this we could say that a hygrometer is used to measure the amount of humidity in the air and to diagnose condensation. An electrical resistance meter provides the temperature and relative humidity. Older equipment also includes the whirling hygrometer. We may also be asked a question on our understanding of an anemometer, and to address this we can say that this is used to measure the air movement within buildings to establish ventilation requirements where condensation has been known to be an issue, and this measures the air movement around ducts, grills, windows and doors, where we could use this piece of equipment to check these areas. And wind speeds to external faces of buildings can also be checked to establish high levels of exposure to driving rain due to the location of a property. The next question we'll take a look at is, what are the key building elements you would typically look to inspect and look to survey? And to address this we could say that we would normally pay close attention to roofs, walls and cladding, any rainwater goods, windows, doors and joinery, the structural frame of the building, the substructure and basements, the ground floors and raised floors, any finishes, internal walls and partitions, the staircases of the property, any sanitary fittings, building services, and finally any outbuildings. We may also be asked a question from the assessors on what are some of the key valuable sources of occupiers information you would normally look to obtain prior to the survey of a property. And to address this we would reference any structural alteration drawings, any guarantees in respect of the premises or its services, any flooding or boundary documentation, documentation on items of fixed equipment likely to be removed by the occupiers, records of service agreements on items of plant, any records of testing of life safety systems, water hygiene and Legionella reports, planning and building control applications and approvals, any documentation on the operation and maintenance manuals, asbestos registers, any documentation on radon tests and high alumina cement tests. We may also be asked a more specific question on what precautions we would take if we were to inspect a flat roof by using a stepped ladder whilst lone working. We would first of all prepare risk and method statements before undertaking the survey. We would also consider the height of the roof, and if it was more than a single storey in height, I would arrange alternative access. We could also say that we would consider the type of ladder being used and state that it must be capable of being placed against a wall at an angle of 70 degrees, allowing the surveyor to undertake the inspection of the roof without standing on the last 4 rungs of the ladder. We could also reference that we would consider if the roof was fragile or suitable to be walked on, and even if it was suitable to be walked on, I would not suggest that this was appropriate from a ladder unless there was a fixed ladder in place. Another follow-on question relating to this area is, if you were asked to inspect a flat roof, talk us through the inspection process you would undertake. And to address this, we could firstly say that we would gather historical information about the building and details of any current or previous issues with the roof, making arrangements for access and preparing any necessary risk and method statements. We would first of all identify the age of the roof, establish any previous repairs having been undertaken, and establish when the roof is known to be defective. For example, when does it leak? Is any ponding water present on the roof? The use of the room from the occupied space below, the use of any balconies or terraces. We'd also consider the access arrangements, and secondly carry out a physical inspection during or after any period of rainfall. We may also be asked a question on our awareness of any RICS documentation that provides guidance on undertaking safe inspections, and to address this we could reference the Property Inspection Technical Guidance for completing of single surveys. We could also reference more recently the COVID-19 Guide to Surveying Services, and finally we could also reference the RICS Guide to Surveying Safely. We'll now take a look at some questions focusing on the construction technology competency. Under this competency we may be asked a question on our knowledge of the different types of pile foundation methods, and to address this we can first of all reference sheet piles, secant piles, board piles and precast piles. We may then be asked a follow-on question on our knowledge of how board piles work, and to address this we could say that an auger is used to excavate the soil, concrete is then poured in along with any reinforcement that's required. Another question we may be asked is what advice would you give a client who was wanting to know the technical disadvantages of a steel frame construction? And to address this we could say that we would make the client aware that the steel frame requires fire protection, parts or individual parts may need replacing over time. The price of steel is incredibly volatile and may create risks within the development. It also requires experienced, skilled builders, resulting in additional cost, and these kind of resources may be hard to acquire. We may also be asked a question on our understanding of the term buildability, and to address this we can say that buildability refers to the practicality and ease of construction associated with the design, and the main contractor's expertise around buildability should help to realise improvements to both ease the construction and realise the efficiencies that are available from the design. The next question we'll take a look at is what are the benefits of off-site construction compared to in situ? And to address this we can say that safety hazards such as falls from height are more likely to occur on site than in a factory environment. Quality of construction should be improved from the manufacturing process within a controlled environment. Sustainability can be improved through reduced waste and power generated from renewable sources. Speed of delivery can be increased as work off-site can be undertaken in parallel to works on-site. The next competency we'll take a look at is legal and regulatory compliance. And the first question we'll take a look at under this competency is a very high-level question, checking our understanding of the building regulations. And to address this, we can say that the building regulations are made under powers provided in the Building Act in 1984 and apply in England and Wales, and they exist to ensure the health and safety of people in and around all types of buildings, for example whether that's domestic, commercial or industrial, and they also provide for energy conservation and cover the access to and the use of buildings. A follow-on question we may be asked in relation to this is what is deemed to constitute building work under the Act? And to address this we can say that building work is defined in Regulation 3 of the Building Regulations, and the definition means that the following types of project amount to building work, and this could be for the erection or extension of a building, the installation or extension of a service or fitting which is controlled under the regulations, an alteration project involving work which will temporarily or permanently affect the ongoing compliance of the building, service or fitting with the requirements relating to structure, fire or access to and the use of buildings, the insertion of insulation into a cavity wall, and the underpinning of foundations of a building. We may receive a follow-on question checking our understanding of when the building regulations apply, and to address this we can say that the building regulations apply to any building that involves the erection of a new building, the extension of a building, the material alteration of an existing building, the installation, alteration or extension of a controlled service or fitting. The next question we'll take a look at is checking our understanding of the approved documents under the Act, and to address this we can say that these provide practical guidance on methods to comply with the functional requirements of the building regulations, and this is contained in a series of 14 approved documents. Another question we may be asked in relation to this is our understanding of the different approved documents, and I won't read through all of these, but we could reference any of the shown approved documentation, For example, things relating to whether that's structural, fire safety, ventilation, hygiene, conservation of fuel and power, glazing safety, and electrical safety. The next question we'll take a look at is what is the difference between an approved inspector versus building control? And to address this, we can say that approved inspectors are businesses which work in the private sector as an alternative to local authority building control, whereas an approved inspector will be registered with the Construction Industry Council to advise and guide clients about the building regulations. The next question we'll take a look at is what is a full plans application? And to address this, we can say that a full plans application can be used for any type of building work and gives the added protection of having the plans approved. The full plans application is deposited with the local authority, usually together with 25% of the full charge payable. With agreement, work may be started after 2 working days. However, before the plans are checked and approved, it is at the client's own risk, and you will be invoiced for the remaining part of the charge after work starts. You must inform the local authority at certain stages of the work so that they can carry out inspections to confirm that the building work is in accordance with the approved plans. And on satisfactory completion of the building work, you'll be given a completion certificate. The next question we'll take a look at is what is a building notice application? And to address this, we can say that a building notice cannot be used where the building is a workplace, as identified in the Regulatory Reform 2005. The notice is served on the local authority together with a full charge payable, and work may be started after 2 working days. The local authority may ask for further details to support the notice, and you must inform the local authority at certain stages of the work so they can inspect the works ongoing. As no plans have been approved, it is important that these notifications are given, and on satisfactory completion of the building work, you'll then be given a completion certificate. The next competency we'll take a look at is analysis and appraisal. The first question we'll take a look at is a level 1 question, checking our understanding of a development appraisal. And to address this, we can say that this is an objective financial viability test of the ability. And to address this, we can say that this is an objective financial viability test of the ability of a development project to meet its costs, including the cost of planning obligations, whilst ensuring an appropriate site value for the landowner and a market risk adjusted return to the developer in delivering the project. We may also be asked the follow-on question, checking our understanding of the residual valuation method. And to address this, we can say that the residual method recognises that the value of the scheme is a function of many different elements. A valuer will seek to check the valuation against any market evidence where available, and a valuer can assess the level of return generated from the proposed project and also establish the residual site value by inputting predetermined levels of returns. Where a planning obligation reduces the site value to the landowner and return to the developer below an appropriate level, land will not be released or development will not take place. We may also be asked a question checking our understanding of when a development appraisal is useful, and to address this we can say that this is used to establish the level of affordable housing, to assess the level and nature of planning obligation contributions, and when reviewing land uses. A follow-on question we may be asked is what are the key stages of the residual method? And to address this, we can say that we would establish the development or redevelopment potential within the market for that parcel of real estate in a particular location. We would also assess the value of the completed scheme and assess all the development costs, including an amount for normal profit, allowing for risks and timings of the project, and for the finance costs and interest charges on any capital needed to fund the whole of the scheme. We would then deduct the cost from value to arrive at an estimated land value and determine whether we would proceed with the development. Another follow-on question we may be asked is what is a sensitivity analysis? And this is where you recalculate the appraisal with different assumptions on inputs, for example an increase in build cost or a decrease in gross development value, and seeing what effect this has on the overall profit measures and whether it's still worth proceeding with the development. The next question we'll take a look at is how would you calculate the sum of money available to purchase a piece of land? And to address this, we can say that the sum of money available for the purchase of land can be calculated from the value of the completed development, or the GDV, minus the cost of the development process, including profit. And the complexity in such assessments lies in the calculation of inflation, finance terms, interest and cash flow against a programme timeframe. And the last question we'll take a look at under this competency is what are the key components of a site acquisition strategy? And to address this, we can say that firstly, we would instruct land agents to identify new sites or investigate the possibility of acquiring existing sites for future development. We could then say that we would undertake market research to ascertain the surrounding population mix of potential sites, its adjoining owners, adjoining uses, comparable rents, any interested parties, and the potential for obtaining planning consent. We would then carry out a development appraisal option analysis to select the most suitable site for development and select the site that best meets the development criteria. We would then obtain the developer's approval to engage in negotiation with the existing landowners and commence negotiations with the landowner regarding purchase. We would then acquire or take out an option to purchase the land or existing buildings for development, and then confirm the development agreement with the landowners, investors and various stakeholders. We'll now take a look at some questions focusing on the measurement of land and property competency. The first question we'll take a look at under this competency is, when measuring, what factors are you governed by? And to address this question, first of all, we can reference that we are governed by the RICS Code of Measuring Practice, and we could also say that the purpose of the code is to provide succinct, precise definitions to permit the accurate measurement of buildings and land. This also allows the calculation of the correct sizes, areas and volumes associated with buildings, and provides a common and consistent basis on which to work on. And this is there to provide support to surveyors who are undertaking property inspections, either for the purposes of valuation, management, conveyancing, planning, taxation, sales and letting. And it's there to provide a common framework to measure buildings by. And the code, we could also reference that the code contains a hierarchy of definitions, with the core definitions being the gross external area, gross internal area and the net internal area. We may also receive some follow-on questions to this, asking our understanding of the various definitions contained within the Code of Measuring Practice. The first of all being the definition of the gross external area. And to address this, we can say that this is the entirety of the space contained within the main external envelope of the building. And this is calculated using the measured external area at each floor level of the building. It could include components such as canopies, external balconies, fire escapes, any garden stores, or any voids either over or under structural or stepped floors. And again, another follow-on question we may receive in relation to this area is our understanding of the definition of net internal area. And to address this, we can say that this is the usable space within a building measured to the face of the main external walls. And this would include areas such as atria with clear height above, measured at the base level only. It would include entrance halls, ramps of lightweight construction to false floors, any built-in cupboards or notional lift lobbies, and also any kitchen spaces. The next question we'll take a look at is, what would you expect the percentage of net internal area to gross internal area to be? And to address this, we could say that this really depends on the type of projects being undertaken, for example, whether it's a school, hospital, or office. We could say from our experience that if it were, for example, an office building, I would expect the net internal area to gross internal area to be in the region of 70 to 85%. We could also say that where 70% of net internal area is not really considered to be very efficient, whereas 85% is considered to be an extremely efficient use of the space. We may also receive a question on our understanding of measured surveys, and to address this we can say that measured surveys involve taking measurements of sites or buildings in order to provide accurate drawings to scale. They are usually specified to an agreed level of detail, to acceptable accuracy tolerances, scale, delivery, times and costs, and traditionally these were provided in 2D hard copy line drawing format with topographical plans, floor plans, sections and elevations, and more recently this has been provided in digital format where the end products can be provided either in 2D drawing format or in a 3D model format. We may also receive a question on our understanding of building information modelling, and to address this we can say that building information modelling is the holistic process of creating and managing information for a built asset, and this is based on an intelligent model and enabled by a cloud platform. BIM integrates structured, multidisciplinary data to produce a digital representation of the asset across its life cycle, from planning and design to construction and operation. That brings us towards the end of this Q&A practice session. I really hope you found that video useful, and please remember to subscribe to receive ongoing APC support.